Okay, gentlemen, we are going to take a look at the work from Tuesday, March 20th. And we're doing day 2 of our mean absolute deviation. So we're going to jump into the activating prior knowledge, which may look very familiar to some of you because it is yesterday's exit ticket. So let's take a look. For a statistics project, 2 students decided to study how many minutes their classmates tended to spend on Facebook each night. The data she gathered is shown below. Calculate the MAD for class B. Okay, so we're given for class A a mean of 30 and a mean absolute deviation of 1.2. We're also given a mean of 30 for class B, and we're to calculate the mean absolute deviation on our own. So I'm going to find the difference between the mean and all of the points around the mean in their absolute value. Okay, so the 20 is 10 away from 30, 23 is 7 away from 30, 40 is 10 away from 30 the other way, plus 30, that's 0, and then 37 plus 37 is 7 away from 30, and I have 1, 2, 3, 4, 5 sets of data. All right, so I'm going to end up with 34 divided by 5, and that's going to give me a mean absolute deviation of 6.8. And now you remember yesterday while you were taking your exit ticket, I said part B is going to be super important in order for you to show me that you've mastered this objective. So comparing the mean absolute deviation for each class. What inference can you make about the Facebook habits of all students in class A and class B based on the MADs? Okay, so what I can say is that in class A has more clustered data. And they all spend close to 30 minutes on Facebook a night. Okay. Class B has more variability and the data has a greater range. So we've been using these mean absolute deviations to compare different sets of data. And we've been comparing different sets of data with basically the same mean and seeing typically one of those sets of data would be clustered and one would be more spread out. But you might be asking yourself, can I use the mean absolute deviation when comparing data even if I don't have the same mean? Can I make inferences about data even if I'm working with different sets of data that have different means? And the answer is yes, you can. Okay, and we're going to take a look at doing that today. So we're going to take a look at our guided practice here. Okay. So the spreadsheet and dot plots below show June and Mia's math test scores from the last quarter. So we're being asked to calculate the mean and the MAD for each student. Okay, so June had a 94, an 88, a 90, a 92, a 95. Mia had an 88, a 60, a 70, a 75, and an 80. And we have here a little histogram, dot plot, I guess it's not really a histogram, or not really a dot plot, sorry. And we have our X's here to indicate the test scores. And so when I'm looking here, I've been given the mean, All right, so I don't have to calculate mean. We know how to calculate mean. But what we do need to calculate is the mean absolute deviation. Okay, so I'm going to look at June first. All right, and his is 91.8. And you know what? I'm going to make it equal 92. I'm going to set it equal to 92. Okay, so it's about 92. Just because I don't feel like dealing with a bunch of decimals right this second. All right, so the difference between 94 and 92 is 2. Difference between 92 and 88, that's going to be 4. The difference between 90 and 92 is 2. The difference between 92 and 92 is 0. And the difference between 92 and 95 is 3. Okay, I'm going to throw these over each other. So I have 2, 4, 2, and 3. 1, 2, 3, 4, 5 set pieces of data. And that is going to give me so 2, so 6, 7, 8, 9, 10, 11. I'm going to have 11 over 5, okay, which means my mean absolute deviation for this set of data is going to equal 2.2, or 2 1/5. Okay, so that's my mean absolute deviation here. This is for June. Now we will go to Mia, okay? So Mia's mean here is 74.6. I'm going to round that up to 75 for our purposes on this video. All right, and so the difference between 75 and 88 here is going to be 13. Difference between 75 and 60 is 15. The difference between 75 and 70 is 5, plus 0, 75 and 75. And then another 5, another difference of 5. And again, we have 5 tests. So when I add these all together, I have 13 plus 15 plus 5 plus 5. And that's going to give me 38. So I have 38 over 5. Okay. And so that's going to give me, let's see, 7 3/5, so we'll say 7.6. Let me move this down and make it a little neater. Okay. My mean absolute deviation is 7.6. So even though I had two different means, I can still take a look at this data and compare the mean absolute deviations and come up with some inferences that I can make. And so this question here, let's move down a bit. What do the differences in the means tell you about June and Mia's performance? So if we remember, June's mean was 91.8, or we said 92. Mia's mean was 75. Okay, so we can say that June will typically score higher than Mia. And when I take a look at the mean absolute deviation, what does that tell me about June and Mia's performance? Well, because June has a mean absolute deviation of 0.2, and Mia has a mean absolute deviation of 7.6, we know that June has similar scores across all of his tests. And we know that Mia has a greater variability of test scores. Get that down, and then we will take a look at our homework. All right, let's take a look at our homework. Mr. Carter's golf scores were 70, 65, 75, 55, and 50. His average score is 63. When you see an average, when you see the word average and they don't actually tell you which measure of center it is, you're assuming it's the mean. All right, so he has a mean score of 63. Find the mean absolute deviation of the data set. Okay, so I'm going to do here the distance from, and I'm going to show you this in a little bit of a different way, just so that you can see exactly what I'm doing. So the distance between, the absolute value of the distance between 63 and 70, plus the absolute value of the distance between 63 and 65. Okay, the absolute value of the difference between 63, 75, plus the absolute value of the difference between 63 and 55, plus the absolute value of the distance between 63 and 50, okay? And I'm going to take that all, and I'm going to divide it by the number of points, and that's 5, okay? So the absolute value here between 63 and 70 is 7. The absolute value between 63 and 65 is 2. The absolute value of the difference between 63 and 75 is going to be 12. Between 63 and 55 is going to be 8. And between 63 and 50 is going to be 7. Add that all together and divide it by 5. Okay, so I'm left with 7 plus 2 plus 12 plus 8 plus 7. And that's going to give me 36. I divide that by 5, and I'm going to get 7 1/5, or 7.2. So my mean absolute deviation here is 7.2. All right, moving on. Finding the mean absolute deviation of the following set. So this is Miss McGrath's golf scores. We have 90, 97, 104, 95, and 94. So what I'm going to do is I'm going to add these all together. 90 plus 97 plus 104 plus 95 plus 94. That's going to equal 480. I divide that by 5. Okay, and I get a mean here of 96. So the mean is 96. I'm not going to write this whole absolute value thing out again for you. So I'll tell you the difference between 90 and 96 is 6. Difference between 96 and 97 is 1. Between 96 and 104 is 8. Between 96 and 95 is 1. Between 96 and 94 is 2. All right. I'll add them all together, divide by 5. So I have 6 plus 8 is 14, 15, 16, 17, 18. So I have here 18 divided by 5. Okay. And this gives me, what's that? 3 3/5, or 3.6. So my mean absolute deviation here is 3.6. Okay. So who had less variation? And how do I know? Okay, well, it's Miss McGrath had less variation. Had less variation because the mean absolute deviation of her data set to her mean was smaller. And golf is a totally weird sport in that The lower your score, the better. So overall, it looks like Mr. Carter probably has a better golf game, right? Because his mean was 63 and Miss McGrath's mean was 96. But it seems that Miss McGrath has a more steady golf game. Okay, so that is our mean absolute deviation day 2. Again, the only difference here is that we're comparing mean absolute deviations with sets of data that have different means. And I hope you guys have an awesome night.